Today I'd like to tell you about some of the real-life materials that can be used by some of the fictional Avengers. Let's start with Captain America. The Cap's shield is technically made of vibranium, a fictional metal that absorbs all vibrations and uses the mechanical energy to make itself stronger. Nothing like that exists, of course, but shape memory alloys, like nitinol, come close. Nitinol can change its crystal structure while still in solid form. If it is deformed at a lower temperature, in the martensite phase, heating it up to the austenite phase causes it to remember its old structure and essentially repair itself. This same process can also happen under changes in pressure as well as temperature, and as the structure changes, much of the mechanical energy put into the system is dissipated as heat energy. It's not quite vibranium, but nitinol has remarkable vibration damping abilities. Let's move on to Thor, Norse god of thunder and wielder of the mighty hammer Mjolnir, which is made of another fictional metal called Uru. Uru is so strong that Thor's hammer had to be forged at the center of a star, which can reach hundreds of thousands of degrees. No known metal needs that much heat to melt, but the closest we get is tantalum hafnium carbide, which has a melting point of 4,215 degrees Celsius. It's a solid solution of tantalum carbide and hafnium carbide, both of which have a rock-salt cubic crystal structure. When they combine, they usually keep the structure, which is held together with, among other types, some very strong covalent bonds. To melt a substance, you have to give it enough energy, or heat, to weaken its bonds so the individual molecules can separate from each other. Since tantalum hafnium carbide is held together in such a strong, orderly structure, it takes a ton of heat to melt it. One of the great mysteries of the Marvel Universe is how the Incredible Hulk's famous purple pants always survive his titanic transformation. While no known fabric or fiber is yet able to keep up with his variable physique, alginate polyacrylamide hydrogel might be. It's a substance, well, really a hybrid of two substances, that can stretch more than 20 times its size without any permanent deformation. Alginate gels are polymers that bond to each other, or cross-link, ionically. Polyacrylamide gels form covalent crosslinks. When the two are combined, they still cross-link to themselves, and also form new covalent bonds to each other. When it's stretched, the covalent bonds stay put, preserving a sort of map of their original structure, while ionic bonds are broken and allow the molecules to move away from each other. Pants made of this would be impractical for most of us, but for Bruce Banner, they'd be elastic enough to protect his hulking decency. And last but not least, my personal favorite, Iron Man. Tony Stark's famous Iron Man suit is a complex machine filled with electronics and sensors and completely bulletproof, but still light enough to fly at supersonic speed with the aid of rockets in his hands and feet. If it were all actually iron, or almost any kind of metal, it would be almost impossible for him to do all that. Piezoelectric ceramics can help keep the computer part of the suit light, at least. They change shape in response to an electric field, and vice versa, and include many naturally occurring crystals like quartz, as well as synthetic materials. This is a simplified explanation, but basically the pressure placed on the material shifts the atoms enough that the positive and negative charges are out of sync, making a dipole and an electric field. They are already used as durable, lightweight electronics in many devices. Now to keep him bulletproof, structured polymer composite is made of alternating glassy and rubber layers, only a few nanometers thick. The glass provides strength and stiffness, while the rubber provides enough elasticity to absorb the force of an impact. It's ideal for Iron Man's suit, as it is extremely thin and lightweight, but still effective. Finally, Iron Man's suit has to protect him from the elements, specifically temperature. He could be exposed to some heat from air resistance, some cold from altitude, and definitely a lot of heat from the burning rocket fuel. If anything can insulate him from all that, it's aerogel, the lowest density solid known to man. It's made by drying out traditional gels and replacing the liquid with a gas to preserve the internal structure while making the overall substance much, much lighter. Heat is just the vibrations of atoms, and it is spread when atoms bump into each other. In a gas, they're farther apart than in a solid or liquid, so they don't conduct heat very well. Since aerogel is mostly made of pockets of gas, it can insulate against heat better than almost any other material. So if the real world was cool enough to have superheroes, instead of vibranium and Uru, they might have nitinol shields and tantalum hafnium carbide hammers. They might be outfitted in alginate polyacrylamide pants, or suits made of piezoelectric ceramics, structured polymer composite, and aerogel. Whatever the Avengers need, materials engineers will have them covered.